We are going to learn about 1.1 Part 2. So this is actually 1.1 in your textbook. So we are going to go through the notes. So this is just real basic information about statistical thinking and also experiments or observations that you will be conducting throughout the semester. So the key concept, the process involved in conducting a statistical study consists of prepare, analyze, and conclude. So if you look at the second slide right here, this is the flow chart. So you start with prepare, then you analyze the data, and then you make some sort of conclusions. So we're going to go through each one of these processes. Just real brief, because later we'll get into it more in depth. So this is kind of like an experiment. Think back to the scientific method. Do you remember that back in the day whenever you had to do like a science fair? You had to follow certain protocols. You had to name your variables. You had to say your hypothesis. You had to conduct the experiment. You had to write your results and what you learned from it. So this is a lot of what happens in statistics. So statistical thinking involves critical thinking and the ability to make sense of results. So you're not just getting an answer. The answer is 7 and being done with it. That's not how statistics works. You get the answer or you get some kind of p-value, which we'll talk about later on the semester, and then you make sense of it. You figure out, what does this mean in the realm of this data or in this question or observation or experiment? So this is so much more than just doing some kind of calculation. So that's what makes it a little bit different from college algebra. So let's look at what prepare goes through. So it says context. What does the data represent? And what is the goal of the study? Source of the data. Are the data from a source with a special interest so that there is pressure to obtain results that are favorable to the source? So I wanted to talk on that one real quick. My husband got a phone call yesterday, and it was one of those 877 numbers. Usually just hit decline. Well, he decided to answer it. And they said, do you have a moment to answer our survey? And so he was like, well, what is this about? And they said it dealt with something to do with politics. So he was like, well, who is funding this research? Who's paying you to call me? And she's like, well, if you don't want to answer, you don't have to. But we can't tell you that because that might change your answers. So we don't get to tell you that. So this is kind of where this comes from, the source of the data. So if they tell you, hey, I'm part of a certain party, you may answer more harshly or less harsh. So depending on who's getting the information. So that creates some kind of bias, and you don't want to create a bias because that skews your data. Okay, the sampling method, were the data collected in a way that was unbiased, or were the data collected in a way that is biased, such as procedure in which respondents volunteer to participate? So we're going to talk more on those. Then you're going to analyze the data. We have graphs that we're going to look at. And then you're going to explore the data. How is it distributed? Is there data that's missing? Did people refuse to respond altogether? And we're going to use the calculator a lot to be able to analyze and get some kind of information. And then we'll conclude. Do the results have statistical significance or do they have practical significance? So that word significance means it is important. It isn't just something that could happen by chance. It could actually, it happens based on, let's say, some kind of pill being taken that caused this result to happen. Okay, so let's look at our first observation. So here is some data that was obtained. So we have pleasure boats and manatee fatalities from boat encounters. So we have two variables here. So usually whenever you have two variables, you're looking to see, is there some kind of correlation, causation? Remember those back in algebra? We want to see what kind of relationship they have. So the table includes the registered boats and then manatee fatalities, each with boats in Florida for each of the several recent years. So the format of the table suggests the following goal. Determine whether there is a relationship between the number of boats and the number of manatee deaths from boats. So you're looking to see, is there some kind of correlation? Did one cause the other? I think they're trying to show that the boats, pleasure boats, are causing manatees to die. So you want to look at the source of the data. It tells us that the source is the Florida Department of Highway Safety and Motor Vehicles. And also for the manatees, they found this information from the Florida Marine Research Institute. So those are very professional organizations. They weren't looking to gain from this. So that's what causes bias if a company is looking to gain something from it, from proving this or that. So the source certainly appears to be reputable and unbiased. The sampling method, they just gathered the data from those agencies. They just got them from records, government records. So that's reliable. So the sampling method appears to be what's called sound. You want a sound sampling method in order to go further into analyzing it. Okay, so let's keep on going. So a way to gather data would be from government records, like that last one, or from what's called a voluntary response sample. So the word here, voluntary, that means you decide whether you want to do it or not. You're not forced to do anything. So this is one in which the respondents themselves decide whether to be included. So like my husband getting the call yesterday, that was voluntary response. They called him, but he didn't have to answer the questions if he didn't want to, which she ended up hanging up on him because he asked those questions. She didn't want to ask the questions after that. I don't know. So we have a couple of different voluntary response samples. So these that I'm about to give you, they're flawed. So the following types of polls are common examples of voluntary response samples. By their very nature, all are seriously flawed because we should not make conclusions about a population based on samples with strong possibility of bias. So if we don't have good data, we can't report and say, okay, this needs to happen because of our data. It's just biased information. So examples would be internet polls. People online can decide whether to respond or not. Another one would be mail-in. After we bought one of our most recent vehicles, we got a mail-in survey and it had a $5 bill in there. I guess they were trying to persuade us to go ahead and do it. I don't know, maybe get you on that feeling of guilt. You took the $5, but you didn't do the survey. Have y'all ever had that? No. No, I ran out of time.
I just take it and throw it away.
I just took the $5. Yes. Okay. So the other type is the one I talked about, where you get a phone call. But this one's whenever you see there's some kind of advertisement that says, call this to answer this question or to do this survey. So a phone call in polls in which newspaper, radio, or TV announcements say, please call to tell us your opinion. Well, people who are super passionate, they're going to call. Somebody who is like, that really doesn't bother me, they're not going to be the ones to call. They're not going to waste their time. But the passionate ones, the ones that are angry about it, or want their voice to be heard, they're going to be the ones that call it. And so it creates a bias. Okay, let's look at the next slide. So Nightline asked viewers to call with their opinion about whether the UN headquarters should remain in the U.S. But viewers then decide themselves whether to call in with their opinions. 67% of 186,000 people responded and said it should be moved out of the U.S. But in a separate independent survey, where you had 500 respondents who were randomly selected and surveyed, 38% wanted the UN moved out of the United States. So that's a huge difference. So this one was the voluntary response sample. And it was inflated. This one was where you have randomly selected. So it's a random selection survey. And only 38% said they wanted to move out. So see how somebody who's super passionate about wanting them to be moved out, they're going to be the ones to call in. They're going to voice their opinion. But if it's a randomly selected survey, this is more reliable. So I'm going to put that here, more reliable. So even though this one was smaller sample, we're going to say this one's more reliable because it was randomly selected. So that's what that next slide summarizes for us. Okay, let's look at the next part, which is analyzing. This is where you're actually going to look at the data. You're going to create some graphs, do some kind of statistical methods. So after completing our preparation by considering the context, source, and sampling method, we begin to analyze the data. So we should begin with appropriate graphs and explorations of the data. So we're going to go back to 6th, 7th, 8th grade. I think we saw a lot of charts and graphs, even elementary school. We have bar charts, we have scatter plots, dot plots, circle graphs, all of those. So we're going to look at those in chapter 2. So a good statistical analysis does not require strong computation skills. Our focus is not on, can you plug in the numbers to the formula? What we're focusing on is looking at the data and being able to make sense of that data. So it does require common sense and paying careful attention to sound statistical methods. So we have two types of significance. We have statistical and practical. So statistical significance is achieved in study if the likelihood of an event occurring by chance is 5% or less. So let's look at the idea of births. 50-50, right? You either get a boy or a girl. So if 98 girls out of 100 random births happen, that is Crazy, right? Is that likely to happen? 98 out of 100 to be girls? Not likely at all. So whatever they did to get that result caused statistical significance. So this is a way of coming up with some kind of conclusion. So it's an extreme outcome. But what if we look at 52 girls out of 100 births? Is that likely to happen just by chance? It really is. So this is not statistically significant because that event could easily occur with random chance. So that's what it means by statistical significance. The event could occur with random chance. Or if it cannot occur by random chance, that's statistical significance. So that's what you're looking at. You're comparing your results to what would happen by chance. What's the probability? Practical significance is more of looking at common sense. So it's possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. So we have an example of an actual company that said, hey, I can increase your chances of getting the gender that you want. If you just do this, if you just take this pill, then you're more likely to get this kind of result, this kind of baby, a boy or a girl, whatever it is. So it says, suppose that the product was tested with 10,000 couples who wanted to have baby girls, and the results consisted of 5,200 baby girls born out of the 10,000 births. What do y'all think about that?
Reasonable.
So
It is realistic.
let's see. What is that probability?
52%.
Yeah, so 52. Because we can do like that. 52 out of 100. What's the, just by chance?
Not
So the results that we actually get, we don't know how to get there yet. So I'm just going to tell you what the percent is. So the result is 0.003% that's going to occur by chance. This is something we're going to learn how to do later, but we don't know that right now. So this is by chance. So we compare this. This is smaller than, so it's less than 0.05%. Sorry, my kind of went together. So that means it's statistically significant. But the thing is, we're going to come over here and talk about practical. Common sense tells us, is that really raising it enough to risk? You know, you taking this brand new pill, what other things could it cause? So it says it is statistically significant, but it lacks practical significance because it's only slightly above 50%. Couples would not want to spend the time and money to increase the likelihood of having a girl from 50 to 52%. And it says in reality, girls is actually 48.8%. So this is not practically significant. Okay, we just need to go over a few pitfalls that can happen as we're analyzing data. So misleading conclusions. When forming a conclusion based on statistical analysis, We should make statements that are clear, even to those who have no understanding of statistics and its terminology. So when we write our conclusion, we're going to write it in layman's terms. We have the math to back it up, but we are going to say, this is what was found, and make sure people can understand it. Our sample data reported instead of measured. When collecting data from people, it's better to take measurements yourself instead of allowing subjects to report their results. So if you're going to go around and say, how tall are you? Some people could say, I am 5'5". But am I really 5'5"? No, I'm like 5'2". But I'm going to tell you, my driver's license says 5'4". I thought I was going to grow a little bit more, and I didn't. Do what? If survey results are not worded carefully, the results of the study can be misleading. I've answered a survey before, and the way the questions were worded, it was like trying to make you feel bad for answering honestly. It was like, do you feel like you should help the custodians by cleaning your own tables? It's like, well, I have a lot of other things to do as a teacher, but you're making me feel like I should say, yeah, I feel bad for that, or I should help the custodians. It was a very misleading survey. Order of the questions. Sometimes survey questions are unintentionally, loaded by the order of the items. So like gradually trying to make you feel bad for answering certain ways. A non-response occurs when someone either refuses to respond or is unavailable. So you've got to keep track of how many non-responses you have. Those count too. Some studies cite misleading percentages. Note that 100% of a quantity is all of it. But if there are references made to percentages that exceed 100%, such as references are often not justified. So if somebody says 300% of blah, 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 said this, question that. Because they either have a typo or they're trying to mislead you.